right. Hi, everyone. I hope my voice survives this presentation after 2 days of Slush. I'm Sauraj. I'm co-founder of Prior Labs, and we build foundation models. So before I go into what we actually do, I have a couple of questions for you. I think you got a lot of energy from the last speaker. But the first question is, who here has worked with data in tables, like spreadsheets, databases, CSV files? Let's see a raise of hands. Come on, guys. Let's go. All right. And who has tried to use that data to make some sort of prediction, like forecast your cash flow, or predict like which categories your customer support tickets should be in, or maybe which customer will default on their credit card application? All right, quite a few. So that's what we're going to be talking about today. And that's what we mean by structured data and tabular data. We all know foundation models, right? And these are the companies that come to mind when we think about foundation models. But really, they've ignored this vast amount of data that sits in these tabular and structured formats. That's 80% of all tabular data. We know this field. It's called data science or traditional machine learning. It's been existing for about 20 plus years. And that's the field that we're disrupting by building foundation models for tabular data. In the traditional tabular machine learning space, you have to build a model for every single use case. So if you start with a prediction problem, right? You say, OK, I want to predict what is going to be this patient's risk of deterioration. You acquire some data. You train a model on that data that gets really good at predicting that one use case. Now, maybe you have a second use case, and you want to say, OK, what's that transaction that Fred made? OK, well, you're going to have to get new data, train a new model on that data that's going to get good at that one use case. And if you want to have a third use case, we know where we're going. It's going to be yet another model that you have to train. 3 use cases means 3 models, and that means 3 times the work. Training these models takes anywhere from hours to days to weeks to months. Depends upon the complexity of the prediction problem that you have. And large enterprises have thousands of these models in production. But what if one model could actually handle all of these use cases? Welcome to TabPFN. TabPFN is the world's first tabular foundation model. It was published by us in the Nature journal earlier this year. It is a pre-trained transformer model that has been trained on hundreds of millions of data sets and can generalize to any use case across healthcare, finance, industrials, energy, and across any statistical task like classification, regression, or time series. In our Nature paper benchmarks, we are about 5,000 times faster than previous methods on classification, and 3,000 times faster on regression tasks. The input to the model is a data set, so it's the context to the model is a data set, and the outputs are predictions. And this data set can have any type of data. It could have text, it could have numbers, it could have categories. As long as they sit in this format of rows and columns, our model can work with that data. Released TabPFN 2.5 2 weeks ago, and it is the #1 model on all tabular data benchmarks, specifically Tab Arena, and is the new state-of-the-art for classification and prediction tasks, beating our previous state-of-the-art, which was our first model, which was published in the Nature journal. TabPFN is an open source model. It's been downloaded almost 2.5 million times and has been deployed across thousands of use cases across a variety of different industries and across a variety of different statistical tasks. It makes me really happy to see every time I see TabPFN applied to a new use case in a new industry. And it's everything from oil pipelines to medicine to financial forecasting. And I want to dive into a few of those right now. Specifically, we are working with Hitachi as our customer to apply TabPFN on sensor data to predict anomalies within railway tracks so that we can enable predictive maintenance. I think we have Hitachi here. I'm very proud to be working with them. And we're enabling safer railway infrastructure across Hitachi Rail. And we're not just replacing existing models for Hitachi, but we're also seeing improvements of over 40% on existing baselines that they have. Another one is a biotech, US and UK-based biotech called Oxford Cancer Analytics, or OxCan. We're working with them to apply TabPFN to enable earlier detection of lung diseases. Medicine is a really, really challenging problem, and the impact that TabPFN is having in medicine, we have about almost 200 use cases that have been published on medicine for TabPFN. It really makes me happy. And with OxCan, they're building an advanced diagnostics platform that will be rolled out across the US that will be powered by TabPFN as the core model. We're also working with a global bank where we're working to replace dozens of use cases with one model to forecast liquidity needs across their entire product portfolio. But TabPFN 2.5 is actually just the beginning. And today I want to tell you about a couple of releases that are coming out over the next weeks. And this is actually the first place that I'm going to be talking about them. The first one is going to be a context-aware tabular foundation model, where the input is not just going to be a data set, but it's also going to be textual descriptions so that you can describe what is in the data set, and the model will use that information to reason over the data set to give you even better performance. It's being soft-launched as I speak right now, thanks to our team back in Berlin and Freiburg. And it's going to be called our thinking model. The next one is large data. A lot of the problems in enterprises are built on a lot of data. So we're launching a new model of TabPFN that's going to scale to millions of rows of data points. And lastly, we're launching a causality model. It's going to enable what-if scenarios, something that data science teams spend a lot of their time working on, so that you can think about what is going to be changing, how do you change the data set, and how is that going to change the outcome? And being able to A/B test a variety of different scenarios and predict the outcomes of your data even better. And that's it for today. Welcome to the future of tabular intelligence. Thank you.